Okay, so we are entering the session number 2, the second one today, and we just finished exercise for chapter 7. There are a few more, but you have to work out yourself. Okay, identify the DIY, do it yourself. Try to solve all of them. Okay, we don't have time to solve every exercise. No, we don't have time. I mean, enough time. So the second one we try to do a few typical exercise in draft theory. But before doing so, let me ask you to turn on your audio, video. I would like to take a picture. I would like to make a picture all of you. So please turn on your video, everyone, and then I take a picture, and then we go back to the class. Okay. If you have no camera, then okay, your icon still appear. Uh, but you are on beautiful girl and handsome guy, so please don't shy, you know. Okay, up, so up, so up, so up, please. The effects of everyone. Smile again. Not yet taking the picture. I will wait until all of you show the picture. Right now, I don't see all, please. So I will change the layout so that I can see all of you. Okay. Okay. Automatically. Hồng Quân said cannot open. That's okay. For one cannot, but the other one can. So please turn on. So I see Dương Quy, I see Nguyên, Lê Hoàng, and the two friends next to him. Maybe Hoàng close to the camera, little Hoàng, and so that your friend can go. I would like to see their face clearer. Okay, Hoàng. Uh, so yeah, the other guy close too there as well. Not see on, please. Oh, I will increase the area. Now I can see better. I will maybe I stop the presentation. One moment. Then I can see all of you. Stop presentation first. Stop presentation. Then yeah. Now I see better. I allow 44, 42 because the class have only 32. So so we are in the third week. So I would like to see your face. 42 too much. I mean a little down to left 1 second. Okay. Hoàng Sơn, Hoàng Hưng, not yet. Trần Ngọc One, not yet. So right now, not full class. So I give you another 10 minutes. Oh, sorry, 10 seconds. 10 seconds to show the picture. So Hoàng, what is your friend name? The one with the black jacket? Yes. Tell her his name. Say your audio. Turn on your audio. I want to hear their voice. Vinh. Lưu Quốc Vinh. Right? Good. And how about the next guy? The next one. At the corner. Châu Thanh. So Lê Hoàng, Quốc Vinh and Châu Thanh. Thank you. So good.
Lê Hoàng Châu Thanh.
Nguyễn Tấn Lộc. You cannot show Tấn Lộc the figure, the real face. Nguyễn Tấn Lộc. Camera not work Nguyễn Trọng Nghĩa, not see camera. Đức Tuấn, not yet. Hoàng Hưng, not yet. Okay, so I will press the button now. Okay, then we go back to our class. One, say cheese. Tấn Lộc asked me. Yes, I see you, Lộc. Okay, fine. So, okay, thank you. Next time, don't worry. Okay. In the meantime, I tell you that tomorrow we don't have makeup because the room is not available. Okay, so we have to figure out the next day. And another friend say that on May number 8, I mean next Saturday, also not available. So what is your opinion? Please say in your email or send directly to the class message so that I know your idea. Maybe you discuss together, the whole class discuss together and get a final decision and tell me your suitable suitable day so that we can make a makeup, okay? Discuss the whole class first and tell me your decision later, okay, by email to me, huh? We don't need to hurry, but we have to make up that, otherwise we don't have enough time to cover everything, okay? Thank you. So go back to the lecture. Go back to the lecture, please. You can turn off the figure now. I will show the slide again, okay? Right. So we are entering exercise section for chapter 8. Okay. Again, I don't show simple exercise. You have to read and understand yourself. But before doing anything, please review the theory. Without theory, you cannot solve exercise. Okay? A lot of concept in draft theory. So there are some very simple problem like this. So I don't say anything. Okay? I choose some difficult problem only. So you have the undirected draft, and you also have the directed draft. Directed mean in the connection between any pair of vertices, then you have a direction, okay, direction on that one. And you have the concept degree in and degree out. So those options you can read, okay. Then this considered to be a simple exercise because you should work out one exercise like this within a couple of minutes, let's say 4 minutes at home, okay. So I will move on here. So I focus mostly on the modeling aspect of the problem because modeling is the most important, okay. Modeling means you have to transfer some real life problem to the model in mathematics so that you find out solution of mathematics, and then you can transfer to RAM, write the code to install in computer. And when you input the large scale problem inside with the data very huge, the computer will take care for you. But the computer cannot do the modeling. You are the one who will do the modeling. Remember that. So any exercise in this structure, the most important step will only will be the modeling step. So that's why I choose the modeling one to illustrate. Okay. You have about scheduling of course in university. This is one of the big problem nowadays. Then how can we employ trap to models? Assuming that some course must be taken before the other courses, and that's true, right? You want to study third year, you have to go through every course in first year and second year. If you fail some of them, then you have to retake the exam, okay? Because otherwise you cannot understand the higher level courses. So therefore, the appropriate model for this one should be directed trap. So that I confirm. Then uh, using the model, I mean the graph model, how can we find some particular solution like this one? Okay, the course do not have any prerequisite or etc. etc. So the modeling step is like this. You have to denote the course by the vertex. Many vertex we call vertices. Okay, and the connection must be directed. The HUV mean this course must be taken before the second course. Okay, the one without previous course we call prerequisites. Okay, are the one with the in degree number 0. That means no course before that course. So let's say this is calculus, and you have to learn calculus before you can learn linear algebra, something like that. Okay, but this one is in the first year of the first semester. So when you enter HCMUT, you learn this one firstly. You don't learn anything before calculus. So you have only the R degree, but you have in degree to be 0. You see, and in the 4 year, if you become senior student and if you do some course like performance evaluation, okay, system performance evaluation for the final year, and after that course you will finish the study and you go out from university, go to work. Okay, so that means this one after that one there are no, so this one is not revisit for any other courses. So this one should have our degree 0, something like that. Okay, so that's considered to be clear from the explanation. Okay, we try something else bigger and more sophisticated, perhaps. This one you can do. This is undirected. This is also undirected, and this one requires some idea about symbol graph. That means no loop and no multiple edges. Right? Number 7. These exercises. Very simple. But you have to think, you have to solve yourself. Don't forget that, because in the exam we have the easy exercise, also the difficult exercise. So you want to draw, yeah, this is for you to draw. Complete, combine, complete by time, cycle, wheel. And how about this one, guys? The last one, what's the name of this? Q4. We call Q4 to be the NQ, where N to be number 4, right? And in terms of mathematics, actually the Q4 is the Cartesian product of the two, actually connecting of the to Q3, where HQ3 is a cube in three-dimensional space, you know. You see what I mean, right? So this is Q3. Hyper Q, in this case we have N to be number 3. And you know how to draw Q3 in 3-dimensional plane. Right? I mean the hyper Q can be defined recursively. This is the hyper Q. And in the hyper Q like this one, you have 8 vertices because using the n-bit string. So if you choose n to be number 3, then you get 8 vertices. Okay. And if you want to connect with another Q3, then you can get Q4. So that means you have to draw another Q3 right here. Understand me? So you have two different hyper Q in 3-bit representation. Okay. So the problem is how can we define the Q4? Because the vertex inside Q4 will have 4 components. So you see the problem is you cannot draw in 4-dimensional. You can draw in 3-dimensional only. You see. So if we draw here, so let's say 0, 0, 0. If we consider only in 3-dimensional, then this one also 0, 0, 0. You see. The problem is when you move to the Q4, any vertex must have 4 components: U1, U2, U3, and U4. Understand me? Where the UI must be binary. Binary means only 0 or 1. So you have here 3-bit string, and this is also 3-bit. But this one, we need to have 4 entry. You see? So that means must be in 4-dimensional space. So we need to investigate something else, and the problem is just thinking to be very smart here by assuming that any point in the first Q3 here start with number 0, so that we get this, and any the node here in the second Q3 start with number 1 perhaps. Okay, in that way you can extend. Okay, so let's say in the first Q3 here you have the diagonal 1, 1, 1, and then you want to embed that one into Q4. You have to put by default the first Q3 here must be start by number 0 everywhere, and this one originally again also 333, but this one belongs to the second Q3, and by the convention we have to put number 1 before, and then we done. You see. And then thinking about the edges, the Hamming distance must be number 1, and that's true if you connect this one to that one, and then you know how to connect this one to that one as well. Then you get the full picture of Q4, and that's done for you, and I just help you the last one. Okay, question number 8 done. And then we move to the next concept we call bipactile. Bipactile and asking you which value of n Well, for instance, the Cn here, you have to prove a mathematical theorem. This is a theorem saying that the cycle Cn only become by time if the value n to be even number like C4. This is C4. C4 the cycle like this one you can prove formally by time. So if we did not the vertex to be V, you have to define formally what is the first component A, and then what is the second component B, so that the vertex V can be written down in this way. Well, so maybe this one A and this one B, and then this one become X, this can become Y. You see what I mean? So you have to say the X and Y here connect to A and B, right? So the X and Y go into B, understand? Meanwhile the A go into A, and also this one belong to A, because we are applying definition of by time. The vertex B also belong to first group, etc. And it turned out that the condition for the cycle will be even number. You have to prove that mathematically. This is a theorem, okay? I ask you to write yourself, and by the same idea, you have to think, say yes or no, but not only that, you have to explain why. Wn mean the wheel mean the cycle, and you put the center inside. Very interesting, this one. The wheel is not by time for any n. Why not? You have to explain in your notebook. Okay, you have to write, do it yourself. Okay. Finally, the hypercube is always by time for any n from 2. Interesting. Very interesting, the last one. Again, follow my idea here. You have to thinking about decompose the vertex of the Qn. So the Qn formally written like V and E, remember, for the hypercube, and the vertex V actually will be the set of on and the bit string, remember? So this is the notation for that one, the set 0 and 1 binary, and take the Cartesian n time, you see? So for this one, if for instance I choose n to be number 2, you understand what I mean? Then this one become the Cartesian product of the binary symbol, but only 2 times if you choose n to be number 2. And you can write down that by using the pair. You get the first 0, 0, and you get the second one 0, 1, you remember? And you get the 1, 0, and also finally you get the 1, 1. You have 4 elements inside the Q2, right? And we say that you have to prove mathematically. Interesting. So you have to define how many distance, and you have to say something, okay, to make sure that the hypercube is always by time, no matter n equal to number 2 or number 3 in the 3-dimensional, or number 4 or whatever. And so that means the roof must be general. You can draw the smallest case to think, but the roof, the mathematical roof must be abstract. Okay. So I provide some clue, some hint for you in that way. Try this one and that one. Very interesting. I will do the most difficult one to illustrate only one exercise because we don't have much time. So this one considered to be easy, but again, pay attention to last one. Interesting. Okay, I provide the solution here for you with the method to prove that one. To know specifically the number of H's in the hybrid Q, and the method will be induction. Okay, and this is the first step, the base step, and this is the inductive step. And by the idea I explained before, okay, remember Q4 is a 2 copy of Q3, remember, and this is the argument. Okay, so so which one is the most interesting? I would like to explain explicitly for you. I will go further and you later, because the one here you have to work out yourself. Everything here, everything here you have to review the theory and solve yourself, because in the final exam the time is very limited. So if we have to interesting problem, then we have to delay until next time, otherwise we can illustrate today. Okay, so let's say this one. Yes, so I choose this one easier. Beginning, we talk about buyback time, and I give you this draft. This one buyback time or not? The same answer is yes. So that means I have to define the set A here. The first ACE, yeah, A here, C here, E here. And I have to define the second component of the vertex set B. Remember, the vertex set is already not by V. So if I say so to be by time, I have to be able to decompose, okay, to cut the vertex into disjoint subset. Disjoint is in notation for the union and disjoint. A union B to get V and their union, their intersection will be empty. We're going to disjoint subset. Okay, the one here must be empty. That means they don't have any common point. They don't have any common vertices. Okay, so let's say ACE, yeah, is there, and then BD, then that's fine. This one fulfilled. That's fine. But how about the connection? So is there any connection from A to B? Confirm. Yes, A to B. And also connection from A to D. Yes. You see that? Don't forget the second condition of buyback time. Very important. The S only allow going from A to B, from capital A to capital B. So I review everything here in the methodology 1 to prove something in general to be buyback time. First, you write this one. Secondly, you decompose, and then you check the second condition. That's all. Okay. So the first one saying that A and B cover vertex at V, and there's union here and production here, and the second condition here, particularly the ending node must belong to A and B, and no other case. So this one, if the left, then the right, if the right, then the left. That's all. Not allow UV belong to the same A or belong to the same B. That's fine. Now about isomorphism. You see a lot of concept in chapter 8. Okay. So now we move to the concept isomorphic. You have to learn your cell theory before going to exercise. Okay? What's the isomorphic graph? So there are two conditions, right? We say that if there is isomorphism, and isomorphism means two conditions here, mean bijection, and that bijection, fulfill the adjacency relationship, so that we call isomorphism. So if you choose here, and you see that this one is the first kind of path, you see, and then you move to the second one, then somehow you see we can move as a path similar like that one. But you have to provide a formal proof by defining, let's say the first graph, vertex V, the second graph, vertex W. So you have to provide a bijection from V to W. And that fulfills the first condition here. The second condition about maintaining the adjacency relationship, you have to prove that. You have to know how to write the second condition. Okay? And you can do the same thing here, right? So, are they also isomorphic? This one isomorphic or not? And etc. etc. I don't know. So I provide you a methodology and you work out yourself. Okay. But let's say the second one, the third, the fourth, the last one is interesting. You cannot guess by looking to the picture. Here you may say yes. Well, because here there are 5, this and also 5 vertices, and 5 edges, and this also 5. So hopefully you can show particular isomorphism. So I summarize here. Oh yeah, we definitely need methodology, because the more graph, the more complexity you see. So how about the G here and the S there? Are they isomorphism? You see? And the E and the F? Well, bigger graph. And then the E, the I and the J. You see? So clearly not happy with the hand solution by hand. By just say no, get the proof. So everything about the positive side, where you want to prove that the two graphs G and H are isomorphic. So isomorphic, you have to rely only on the definition. And it turned out that the definition needs to check in total and factorial bijection, which is not fun job at all. Okay, between the vertex V to the vertex W. And this one is not easy task, you see. But if we look to another aspect, you want to say that the two graphs are not isomorphic. Easier to do. To prove, difficult. To prove not, easier. How can we prove not? So, well, that's similar to say, okay, to prove two students, two guys A and B, let's say Vin and Wang, for instance, they are isomorphic in the sense that their faces are the same, the height of the two children are the same, their score entering HCMUT the same, they was born in the same province, etc., etc., something like that. They are isomorphic in that sense. But if you say not, then you can say, okay, just one factor, like Wang was born in March and Vin was born in December, then done. They cannot isomorphic. You see the idea. So therefore, to prove not isomorphic, you have to figure out some property where the two objects have different value. And that's all, right? That concept we call the draft invariant. The property we are talking about that we call draft invariance. So this is the methodology. Invariant, that means they do not change. It should be the same. That means if they don't have the same, then they cannot be isomorphic. You see the idea, very simple that way. So let me talk a little bit about this, about the graph isomorphism. Oh, sorry, the graph invariant. Yes. So I summarize everything I explained in this slide. Everything is here. You can read later at home, but I will go very fast here. To confirm yes, isomorphic between the two graphs, you rely on definition. Okay, you have to write down implicit isomorphism. That's all. The problem is in last graph, the number of projection you need to check will be very huge, like this one. If the graph having 6 vertices, let's say, then the number here turn out to be, how much are they? 4 factorial, 5 factorial, and 6 factorial is somehow like this number, huge number to check. Okay. Therefore, maybe you want to confirm no, you have to provide some argument that indicating that some certain graph invariant is not the same for the two graphs. Okay. And I define the graph invariant to be a property that does not change under graph isomorphism. The property does not change after isomorphism becomes graph invariant. Then we should use this conclusion. If you find out some invariants that are not the same for the two graphs, then you conclude they cannot be isomorphic. Okay? And the argument is here. We rely on a logic theory. Okay? If the two graphs A and B, G and H are isomorphic, then the invariant must be the same. Therefore, if some invariant not the same, the two graphs cannot be isomorphic. See? So apply this one. The first here mean A. Understand? And for every invariant P, they should be the same. So this is the second logical expression B. And the right hand side here will be like this. Okay. Not logically, not mean like this. Then not A here mean not A here. Okay. Because A confirm isomorphic, then not A confirm not isomorphic. And that's all. And that finished the story. We call that methodology 2 in section number 8, lecture number 8. And then the invariant Usually the scientists rely on 1, 2, 3, 4, 5, at least 5 variants. The number of vertices should be the same, the number of edges, the number of vertices of fixed degree, and maybe the number of symbol cycle of fixed length. See? So let's say the version C, we say no, and we look at the problem C. We find out why. Problem C, wait, problem C. Problem C before, not after this. We say no. Okay, let's see why no. Problem C, A, B, C. This one. We confirm there, no. Okay, we say by using the concept graph invariant. Tell me which graph invariant not the same for the two graphs. 1 minute. Focus on problem C here, the picture. This is the graph G, and this is the graph H. Maybe 2 minutes, okay? 2 minutes. Tell me the name explicitly of the graph invariant which is not the same for the two graphs. Because we confirm that section C here, the two graphs are not isomorphic. When say something, degree of one vertex in S is 4, while in graph G max degree of any vertex is only 3. So I will check now. He said that in the first graph G, we count the degree of the vertices. Okay, degree 2 and degree 3 otherwise. So that means the first argument is correct. Graph G maximum degree only 3. Now look into the second one, and we recognize that this one have degree 4. See? So therefore, if you rely on the graph invariant about the degree of the vertices, I mentioned to you before, there after the methodology, remember, we rely on the degree of the node inside the graph. So the degree, maybe this or that, all of them are okay. So we say the number of degree 4 in Vin opinion that if he choose this one, then the number of vertices with degree 4 for the first one is 0, where in the second graph there is one vertex with degree 4. Okay, you see what I mean? So he employed this property. He employed that graph invariant GNS 0 and 1 regarding degree number 4, and the final check will answer. So let's see the picture again. Go back there. The graph C right here on the left corners. Yes. So this one gives you No vertex with degree 4. See? Really? And this one gives you one vertex with degree 4. Exactly this one, right? 1, 2, 3, 4. So Lewin got another point. So today Lewin got in total 3. Is that correct, Vin? Today you contribute 3 times. Yes, so I will record that one. And in the last few weeks you got 2 more. So that means so far the accumulated score you got is number 5 if I'm wrong, if I'm right, okay? So keep doing that because the final exam is not easy to get the maximum score. So this is good. Lewin got another one, number 1. Okay, remember? Record later. So you have 2 methodology newly defined today for the district number 8. But you have to solve the other exercise. Don't forget that. Check this one. Something else here. I provide the answer, but I don't explain. But you can explain number G again. No. And try to work out yourself. And hopefully we have to finish now. The last session is about the representation by matrices. You have the adjacency matrices. You have the incident matrices, and etc. And finally, you have some inequality in graph theory. Inequality, okay? You know the number of matrices, number of edges, and we define some constant like this, maximum degree, minimum degree, and you prove something. You should try this one because in lecture number 9 there will be much more difficult problem rely on this kind of simple problem. Okay, try to do it yourself. Any question so far, guys? Q&A session. Any question, please ask before we stop the lecture today. So right now the number of students drop out to 28 over 49. So we please tell your friend that not miss any lecture. Otherwise the chance to pass this course is very slim. Okay, very difficult topic. You will see a lot more concept, a lot more exercise to work out. If you not go into the class, you cannot listen to my explanation. We see, not cover in the theory part. Any day will be meaningful. Huh? I cannot go back to what I say. So if you miss one theory, then I cannot help you because I have more theory to tell the other class member. Okay. If not, ask a question. So thank you for following me until the last moment. And bye bye and see you. Oh, we don't have the lecture tomorrow. Okay. No lecture tomorrow. Tomorrow means 28. No lecture 29 on this Thursday. Right? But yes, next week. Okay? You see clear, people? Please confirm via the chat box. Any one of you. Tomorrow and the next day we don't have. So try to stay and work out the exercise and the problem of DS7 and DS8 and read lecture DS9 for next Tuesday. Okay. People see clear, huh? Say something. I would like to hear the voice of one of you. Wayne, are you there? Yes? One, Trần Ngọc One, you hear me? Hello? Okay, thank you. Bye.